Hello everyone, Sean Mancini here. Today I'm doing a quick video on the differences between TCP and UDP using some visual learning and and Wireshark. So I've been getting some requests about some basic networking videos and the differences between TCP and UDP. So basically, TCP is Transmission Control Protocol. Transmission Control Protocol is a commonly used protocol for applications such as FTP, HTTP, and applications that need to transfer data and ensure that all the data reaches from point A to point B. So the best real world scenario I can put is TCP is kind of like sending a package via UPS with a tracking number. The package leaves your mailroom and goes to your client's mailroom. Now, there is a tracking number, and each time or each place that that package reaches, it gets scanned. You get a notification saying that the package is here, and it ensures that it reaches its destination. UDP is user datagram protocol. User datagram protocol, and UDP is the opposite. UDP is kind of like sending a letter in the mail with a simple stamp. Now that letter will go from the mailbox to your destination, wherever you send that letter, with no guarantee to you that that letter will actually make it. And if it gets lost in the mail, too bad. So there's obviously a reason why UPS to send the same letter may be $5 versus in the mail is $1. In other words, TCP is a heavier protocol where is guaranteed that the packet will make it there, and if it doesn't, if there's some packet loss or a packet gets dropped, it will send the packet back and ensure that it makes it there, and it will keep on sending it until either the application says to stop or some event tells the network to stop sending those packets. UDP sends the packet, and if it makes it, great. If it doesn't, too bad. So the difference is in where the application for these two protocols is first of all FTP. So you transfer files from your desktop to a server. You want to be sure that all of the data in the file that you're transferring goes from your client to the server. So you would use TCP because you need a mechanism to guarantee that if a packet gets dropped somewhere in the network, that the application will realize that and send the data again to the server. And so that is the job of TCP. And you can tell by what this is the TCP header format. So the header format is all the data fields that you'll find in a TCP packet. So source port, destination port, the sequence number, and this is really the bulk of everything. So with this sequence number, TCP will send one packet, and the sequence number, say it's the first packet, will be number 1, and so on and so on. There's TCP flags, I'll get to that in a moment. The window size, which is the size of the packet. There's a data checksum and some additional options. UDP, because it doesn't have the same mechanisms as TCP in terms of making sure data gets there and stuff like that, you'll see that the header format only contains 4 fields: source port, destination port, the length, and header and data checksum. Also note that UDP is not connection oriented, meaning this: TCP does a 3-way handshake. So the client and the server talk, they negotiate a connection, and then send data. UDP does not do this. So that's why you will not find the flags the flags field in a UDP packet, because the flags are used to negotiate that. So if you see TCP has a flag called SYN. So client sends a packet called SYN. The server responds with this SYN saying, okay, SYN acknowledgement, and the client sends another TCP packet called SYN ACK, and then the connection gets established. And you'll see here where that connection state. So connection state will go from SYN sent. The server now has a SYN received, TCP, and then this is where a TCP connection comes. Now, once that SYN ACK is sent to the client, it has an established connection, and it'll send an acknowledgement packet to the server, which will then also have an established connection. If for some reason the client sends the server a SYN packet and the server does not respond with a SYN ACK, that's when you have half-open connections. Half-open connections mean that the server has allocated some memory, and a connection is ready for a connection to happen. However, because it didn't get the ACK packet from the client, it is not in established mode. This is a common technique for SYN attacks. This is in a SYN attack, for instance, a client will send a SYN, the server will send a SYN ACK, the client will not respond with an ACK. So what happens is that this server gets filled up with half-open connections. Okay, so let's see this happen in the real world. So let's pull up a TCP packet. Okay, so you see this packet is a TCP packet, and let's look at some of the data that's in it. So TCP, this is on port 80, is the source port, so this is going to be some sort of web request. And this is a sync packet. So if you go to TCP flags, you'll see SYN. So this SYN was sent to this IP address, or from this IP address. Okay, so you'll see that the source in this case was here, and then there was a SYN acknowledgement that came in. So how do you know that this is a SYN acknowledgement? Well, first, the flags, SYN ACK, and I have two flags. I have two flags set here: SYN set, acknowledgement set. And sorry, so to correct from what I had said before, this is not just a SYN packet; it's a SYN acknowledgement packet. So that's why it's coming from a public IP address. So this is the second packet. So my client, my desktop here, sent a SYN packet to the server, which is that 72.IP, and the server sent back a SYN ACK, and you can see it here. So then there is the window size, which is the size of the packet. Now the window size for 99% of the web traffic does not matter, especially if you're just browsing the internet. Where it does matter is, for instance, if you're transferring large amounts of data across a point-to-point link, for instance, using TCP, you can do some hacks where you increase that TCP window size, which then makes each data packet larger, carrying more data from point A to point Z. And so that's when you start tweaking those. But for general internet purposes, you will not need to really play around with that. And Wireshark really helps illustrate all of this. For instance, the TCP flags, again, AS for acknowledgement and sync. We see, for instance, the other flags that are here. Again, more just general information. But right now, this really illustrates the point. So another cool thing that you can do in Wireshark is if you right click on a packet, you can go follow TCP stream. So let's get out of here. And this is where you can really see the magic, or I shouldn't really say magic, how TCP works. Okay, so TCP works like this. Source. So 2.5 is my client. So 192.168.2.5 sent a SYN packet to 72.21.91.29. That server, 72.21.91.29, sent back a SYN acknowledgement packet to my machine. My machine responded with, you guessed it, an acknowledgement packet. So let's see that compared to the three-way handshake. SYN acknowledgement, acknowledgement. So as you can see, the first three packets here are the TCP handshake. Afterwards, you start to see the data. So now the data is flowing through. Okay. Now, do you see the bottom here? There is fin. Well, what's fin? Fin is when the connection is being sent. So the connection is done at this point, and my desktop machine sends a fin acknowledgement to the server. So what that means is, okay, I'm done, so I'm going to close off the connection. Okay, so kind of a reversing. So fin ACK, and now the server responds, oh, fin, or sorry, in this case, ACK, and then the connection finishes. Again, TCP being connection oriented needs this communication to stop. Let's look at a UDP packet. So UDP, for instance, a good example of UDP is a DNS packet. So a DNS packet, we send, say, google.com. You send that packet. If it doesn't make it, we're not transferring data. In this case, we're just doing a lookup. So you'll see that that's part of the reason why it's on UDP. And also to get those resolutions as fast as possible. So this is a UDP packet for DNS and with a query to google.com. Now let's go under UDP. So you can see right off the bat how much more simpler UDP is compared to TCP. So UDP has a source port, the destination port, okay, checksum, as you can see, checksum unverified, and a stream index. this is the data portion. So this is the DNS request. We don't really need that for this case. But you can see UDP here is pretty basic. And all we have the info is the source, destination is pretty much the bulk of the entire packet. And if we go back here, you can see, yep, source port, destination, that header checksum, and the length. Okay. So I encourage you to use Wireshark and explore the other differences, the subtle differences, some things that I haven't talked about, and differences in TCP, and all of the other little nitty gritties that you can really do with these two protocols. These two protocols run all the networks on the planet. All other sub protocols, for instance, FTP. FTP is a sub protocol of TCP. HTTP, HTTPS. All of those sub protocols are children of TCP. They all rely on either TCP or UDP to transfer data from one end of, so for instance, from the client to the server. At the end of the day, is either a TCP type of traffic or UDP type traffic. I hope this video helped illustrate the differences. And if you have any questions, please leave them in the comment section below. Please also visit my website, www.seanmancini.com, where I do a lot more blog posts and some other topics on that page. Have a good day, everyone.